Celestial bodies, such as planets and satellites, move in paths that obey the laws of motion. The planets move in elliptical orbits around the Sun while the satellites move in elliptical orbits around the planets. The Sun and the Solar System itself move in an elliptical orbit around the center of the Milky Way. The heavenly bodies move in an elliptical orbit due to the attractive force of gravity. The centrifugal motion is balanced by the gravitational attraction. The elliptical orbit is kind of an elongated or skewed circle. Instead of having a single center like a circle, ellipses have two centers called foci, A and B, F1 and F2 in the figure, and where singular equals focus. For planets in space, the center of the Sun is always at one of the foci as shown in the figure. The larger the distance between the two foci, the more elongated the ellipse is. The amount of the elongation of the orbit is given by the eccentricity of the orbit. Most planets have a very small eccentricity. The Earth's orbit has such a low eccentricity that both the foci lie within the Sun itself. So one can say that the Earth's orbit is almost circular. We have had a look at the planetary orbits and their features. Let's now look at the Kepler's 3 laws of planetary motion that describe the motion of planets around the Sun. The first law states that the path of the planets about the Sun is elliptical in shape, with the center of the Sun being located at one of the foci. This is called the law of ellipses. According to the second law, an imaginary line drawn from the center of a star to the center of a planet will sweep out equal areas in equal intervals of time. This is the law of equal areas. The third law states that the ratio of the squares of the periods of revolution of any two planets is equal to the ratio of the cubes of their average distances from the Sun. This is the law of harmonies. For each point on an ellipse, the sum of the distances from each focus is a constant equals 2 times the major axis length. Also, in most planetary systems, the eccentricity is low enough such that we can approximate the average distance between the star and the planet as the major axial length of the orbit, A. Before wrapping up this module, let's look at some amazing statistical data for the third law.